I'm going to talk today about master planning. In other words, not making an entire city smart, but looking at some portion of a city, 5, 10, 15, 20, maybe 100 acres, and thinking about the tools that have changed the way we think about planning these larger projects. Sure, they involve buildings and bricks and mortar and vertical structures, but before that, we think of the plans themselves. So, planning, I understand Rahm Emanuel was here yesterday, so I had to show a little bit of Chicago to balance things out, but this was the plan for Chicago's waterfront, Lake Michigan, more than 100 years ago. So we think of master planning in that period and even to today in places as a horizontal exercise. How do we plan for streets and parks, and literally looking at a plan and placing pieces of use and understanding how we can make parts of a city. And that sort of planning, if I can not quite rely on this clicker, is maybe the sort of plan which we are looking at now in a district of London, shown here, the Earl's Court zone, where a whole new neighborhood will be made. But if we think not so much about this density of city, but this density of city, which, by the way, is the previous image squished together. This is a vertical version of London. You see the London Eye and the Houses of Parliament. But not so much an exaggeration when we think of various cities around the world that are challenged by density to the point where we have to think about more than just the ground plane. So the sort of projects which we're working on today are thinking about these very issues that I think all of the mayors who are here today and yesterday and others who are managing and working cities that need to be thought about in these hyperdense situations. Comfort, mobility, resiliency, flexibility. This is our duty. So we're evolving a new set of tools to work around or with these issues and challenges. So just as an illustration, here are 4 projects in diagram form, which are buildings. They're also clusters of buildings, but more than that, they are vertical master plans. Now, these are places where, even though one developer or group of developers might be at work and the city approves this in one go, the public space moves from the ground to the 3rd to the 12th to the top of building. So the things that are controlled in master plans that should be mandated come into this vertical kind of register. In fact, in Singapore, we're working on a building where there's something called a mandated landscape replacement ratio, where because the building will take green from the ground, we have to put green back into the building in public levels that occur in rooftops and sub-rooftops. So the public responsibility to engage in these sort of large projects. So one of them, to begin with, is Hudson Yards. So some of you visitors to New York, those New Yorkers probably know this very well, but you should visit it if you haven't. These buildings which are shown here are constructed, another 10 or 15 more to go. The technique of how to make this work is very much about a deft engineering and architectural coordination of elements to allow all of this 20-acre plus area to exist as a false or fake ground. This was all railroad tracks until recently, when related companies built, as you can see here in section, not just buildings shown. This is a section through the buildings, obviously. Some of them hung over the tracks, but also a new ground plane. So this is artificial ground. The way that this gets to work, the way we can make a smart piece of a city here, is to make a landscape crust of only 5 foot deep, where plants and trees can exist. The heat from below would threaten to fry the plants, but there's, if you look closely, you'd see refrigerant cooling going through this 5 feet at the point of the tree pits to allow plants to exist where they couldn't otherwise above these tracks. So with some intelligence of engineering, some kind of way to make public space where it couldn't exist in the same way. The Vanderbilt Tower now brings us to a spot right next to Grand Central Terminal. This will be the tallest building in Midtown. If you go to the site, it's about 15 stories in the air. But what's most important about this is really the planning of East Midtown. As New York City Department of Planning has mandated, there should be the ability to add density to this area. because it is the transit node of one of the two great ones of New York. So we know that the passage of people, the commuters coming through Grand Central at peak hour will double given east side access. And that's a smart thing because we want New Yorkers to be able to come from Long Island, not only to Penn Station, but to come closer to their workplace if they're in this East Midtown area. So that little yellow area that's shown here is the site of this tall tower. And so we connect below grade. That's not so adventurous. I mean, it's a good idea, but could have done that 100 years ago. And, but what is interesting is the measurement. And this gets now to the subject of the way data can assist us in understanding the fine-tuning of this part of the heart of a city. This is really the most intense part of New York City. How many thousands of people will come through private property, which is in a way ceded to the public, to allow it to function as one of the sort of hearts of New York that can handle this capacity. So an immense amount of engineering goes into that understanding. The architecture responds by opening up visually the aspects of the lower part of the tower to Grand Central Terminal, sort of a glass lantern next to a stone box. But if we go digging a bit further, a bit deeper into this project, this is, by the way, an image of the plaza between the Vanderbilt Tower and Grand Central Terminal. But if we dig deeper, we look at the process of zoning, which was influenced by a data research project, which was undertaken by Luke Wilson, who is part of our firm, KPF, operating in a kind of a wing of our firm we call KPF UI. So there is a thought about quantifying, with a series of algorithms, all of the issues of comfort that have to do with people's lives inside the building. That's the developer and the tenant's concern, with some of the issues of public good that have to do with light, with wind, with temperature outside the building. So we introduced in, not so much just in this project, but in the larger East Midtown zoning initiative, which is a very important part of what New York has gone through in the last few years, a set of studies where thousands and thousands of options can be vetted with these algorithms to understand how buildings should be shaped to allow for a greater density to occur. That was the goal of New York City planners, to be able to say that top-class companies should be able to move to East Midtown, not only to Hudson Yards or downtown, because better buildings could be put up, and those could be put up if in some critical places more density could be allowed. Because you have to take down some old 1950s buildings that are not functioning, but to do that you have to increase the area allowed. So with this kind of algorithmic testing, we looked at a variety of options, understanding their effect on the street, on insolation, we call it, the access to the sky. So the little building, which you see outlined in orange there, which existed before this tower has been started, compared, you see it here shown in dark gray, compared to the tower itself, there is a very little loss, actually, of sky view, given the taper of the tower. But that had to be measured and tested. And that testing then, not just for this project, but for other sites in East Midtown, took the form of an almost infinite number of options that were looked at so that we can have not a prescriptive form-based zoning, but a performance-based zoning. It's based on how people will feel about light and air and views when they're at the street. And so these tests, rather in the abstract here, were used by city planning to find the densities that could be achieved. They had a goal of X million square feet more in certain sites. But by looking at the effects with some kind of modeling, they could then understand where to draw the limits of the change of what's called a Waldron diagram. It's a technical term that has to do with the zoning envelope. So the various tools that we're using now, we're applying to a variety of master plans around the world. So again, if you can't change a city, a whole city, you can change a part of a city. So in a master plan in Sydney, in the center of the rail station area, or in a part of Shenzhen where a large swath of town is being developed, or in Cape Town on the Victoria and Albert docks, the waterfront, or in Luxembourg, where a large project is underway to create a sort of new city at the edge of old Luxembourg, or in Toronto, you know, some well-known projects. This one happens to be actually out in a green field. So some are almost new cities. And then here at home in New York, this is a plan of Red Hook, of NYCHA housing, of affordable public housing, where issues of resilience. This was horribly flooded during Hurricane Sandy. And this project is all about measuring the way architecture, occupancy, and resiliency can be maximized together. So I'll just leave you with a few views of tools that we're using in these projects. And they're fascinating because they don't generate design, although that's the aim of some of our developer colleagues or clients to see whether we can generate design. But we believe design has prerogatives that need to be negotiated, thought through, and articulated in ways that data cannot comprehend. But still, and these are more illustrative of some of the layers that go through the evaluative process. Of course, how can people move through blocks? Where can green capacities be created? And with that now, for some of our projects, already actively, not just to make us feel good, the discussion about autonomous vehicles versus legacy vehicles is picking up to the point where we can start to say the street will change in this way, that this much area will be released for the cafe or for green, and that's something we could start to measure the kind of utility of, the appeal of. We start to measure the pathways through cities, sometimes for their efficiency, how quickly can you get from A to B to C, but then there's also a cognitive component. Sometimes we take paths through a city that are not the shortest, they're the most rewarding, the most information on the storefronts, the more fun and interesting people to see, something you can pick up to buy, a piece of green you want to look at. These things can be evaluated, and they are being evaluated in quite real ways for the Earls Court Master Plan, which we're engaged with Capital and Counties developers in West London. The issues of comfort are very important in some climates more than others, and of course vary widely in the kind of goals that we have. So when we're currently involved with a very large master plan in the Qianhai district of Shenzhen, there humidity and heat they will defeat, and lack of cover of rain defeat the ability to make good outdoor space. So we have to measure that and see how we can compensate. Or this happens to be this greenfield site north of Toronto. Well, there, wind, along with the humidity, which will increase the chill, and cold will block off certain months of the year. So these diagrams are intended to and do give us feedback on block size, block orientation. How should we plan this part of a city? Then there's the understanding, the measurement of the intensity of use. That could be the density of the buildings. It also could be just the number of people on the street expected given the patterns of movement and the uses that are adjacent to a street. By doing this, we can tune the sizes of streets, but we can also respond with use designations that benefit or don't benefit from throngs of people going by, retail versus residential. These can work their way to very common sense planning principles we all know as architects, planners, engineers, but this gives us something more powerful. And we think of all of the different dimensions of planning. It's very helpful to be able to look at all of this through this quantitative lens. So this represents one block of a project seen in a few hundred different iterations. And every architect in our studio, everybody wants to make a beautiful building of shape and form and space, but we can test how these will react in all of those ways that have to do with efficiency, comfort, sustainability, energy use, surface area, et cetera. And so when we look at all of these techniques together, the trick is we've got all these tools, but we're sort of now like carpenters with tools, and we have to learn how to use them because we've got a whole shop full of tools. How do we prioritize some of these factors? Because sometimes the greatest surface area will give us the best sunlight, but the worst energy performance. We have to look at flexibility as something that will allow us to say that this part of Soho could have started as a manufacturing district becomes an set of art studios, then people live in the lofts. And we know there are some very simple principles that have to do with bay systems and good architectural techniques that give us flexible uses in the future because they're suited to the basic anthropology of the user of the city. But those aspects of flexibility may not give us good specific uses for any of the iterations that a city takes through a neighborhood. So a good loft does not always make a best place to live because the depths might be too big. So putting the tools together has been our current effort in some of these large master plans. And so each of these diagrams is showing you a little bit as an illustration. For example, that was a matter of density and surface area mapped onto buildings and sites in order to see where the trade-offs would be between density, energy use, and actually solar power worked in as one of the priorities for a client in this application. When we look at the distribution of green space, we know we have choices if we're thinking about a 5, 6, 10, 20 block area. Do we aggregate the green into one park? Do we distribute green into site by site? Do we create thresholds that we need to observe that from your apartment or from your workplace, you should be able to get to a park within 5-minute walk? And what are the social and sort of city practice and even economic advantages to having aggregated green versus piecemeal green? Outdoor comfort I mentioned earlier. This has become a big sort of obsession for us in Toronto. So in one case there, we're looking at rotating the grid. We have to choose. Is that block 400 by 600, 200 by 800, New York City block? Is it square like Chicago or Barcelona? But as we turn a given case around, how do different avenues of light and wind react with buildings and building sizes to create a decent plan? If we really have a tabula rasa, which we do in that case. Or here you see just an illustration of a simple orthogonal street grid. There may be reasons to rotate the street grid because it hits another piece of town which is on that other angle. As we know, that happens in many cities where you have an angled street go through a right angle grid, as we know Broadway does in New York. And always looking at density as one of the most important kind of needs of a lot to do with the economics of projects. Where we can create density, we can create tax revenue, which then allows somebody to issue a bond, and then there is the financing to do something that we believe in that is for the public good, which may have to do with transport, for example. I didn't mention it, but in the Vanderbilt project, the play in that project, really what makes it a great project, a win-win project, is that 500,000 square foot extra, which is a huge quantum of space, it must add up to $500 million or more, is given to the developer because of the plugging into the central station, making Grand Central work in the future. So that can sort of be made to happen through discussion with public officials, and that's aided by data illustration of what the benefits are. So I'll just finish up with a reference to a project, and this is a series of sketches that came from a data analysis. So we have an urban designer who was the head of New York City urban design, Jeff Shoemaker, for many years, now working in our firm, and he's really looking at the more painterly side of the quality of space that goes along with what Luke is doing with the quantitative analysis. And so these analyses of mobility, of comfort, of sunlight, and distribution of green ended up with, or supporting, I should say, this design. So it's specific to Shenzhen, it's specific to this site, but it gives us a vision of the kind of architecture which is building, but it's also master plan. It is vertical master planning. It allows pathways in public space to come through the upper levels and make a high-density place with more of those qualities that I mentioned at the very beginning that are so essential to us: comfort, energy efficiency, sustainability, flexibility, et cetera. So there's a little window into a master planning process. Thank you very much.